computer. So welcome everybody to the first meeting of 2026 for the Tucson Amateur Astronomy's Fundamentals Group. This will be basically a things to look forward to meeting in 2026 for astronomy events for those that may or may not have a copy of the club's astronomy calendar. This will talking about breaking this down into three things. We're going to be talking specifically about planetary alignments and planetary events. And you might want to go look out for observing specific planets throughout the year. And we'll then talk about some of the meteor showers, regularly recurring meteor showers that will come up this year, and when you might want to go look at those and which ones might be more worthwhile to look at than others. And then we will finish it up talking about any upcoming lunar and solar eclipses. Although there are no solar eclipses in the US this year, it's still nice for people to know about solar eclipses because they do like to travel with them if they didn't already have plans. For those who are joining us the first time, I'm not quite sure I do see some names I don't recognize. This meeting normally has two presentations, but we've been having off and on just one presentation. Generally, we'll cover a general astronomy topic like tonight's. Otherwise, when we have two presentations, one will generally cover a constellation or a notable astronomer who may have done something that we'd like to know about as amateurs, because it gives us something to go do or learn more about the things that we can do in the night sky. So jumping right on into it for the evening, I'm pretty sure everybody can see my screen before I do continue. I just wanted to double check that because I forgot to do that before starting the recording. Don't have any no's coming up, so moving right along. So for planetary events, these are typically going to fall across into planetary alignment, specifically for the two inner planets, Mercury and Venus. This is a little bit more relevant to them. So starting off specifically, there are a bunch of different positions that a planet can, notable positions that a inner planet can appear in our sky. These are called out specifically as an elongation or within or the highest altitude, which are two separate positions a Mercury or Venus can be in that helped us know when it's more worthwhile to go and observe them. We also have other alignments that are worthwhile, specifically conjunctions, which is when two planets will appear not quite in line with each other, but this is the closest that two planets will appear in the night sky together during a given orbital period. And then we will have occultations and oppositions, which we will talk about separately when we get there. But specifically, elongation and altitudes are only apply to Mercury and Venus. This is where you're only going to see them. The elongation is when the planet appears farthest from the sun. So this is more of an orbital dynamics thing. Farthest it will appear from the sun as it is viewed from Earth, which is slightly different from highest altitude, which is where the planet will be in the sky the longest will have the highest altitude in the evening sky. For Mercury, the greatest elongation, and to a rough extent, the highest altitude. Both greatest elongation and highest altitudes occur within a couple days of each other, generally, as we'll see. But for Mercury, the greatest elongation is between 18 and 25 degrees. And for Venus, the greatest elongation is between 45 and 47 degrees. It varies depending on the specific orbital periods. And this is the angular altitude for when that planet will appear in the night sky, I believe, if I remember correctly. And then one other thing that we'll call up that's also specific to the inner planets is a phase known as dichotomy, which is essentially when the planet appears in a half illuminated phase like the half moon, but only specific to those two planets because like the moon, Mercury and Venus do have distinct phases because of their position relative to Earth. Starting off with with planets, we start off with Mercury, the innermost. This planet has two notable periods of that will in the night sky this year. It'll be best viewed in the evening skies this coming February and this coming and in the mornings this coming November. It has several periods of highest altitude, flip-flopping back and forth between the evening and morning skies as it moves around the sun. Notably here in the evening skies on February, June, and September, before jumping into the morning skies for highest altitudes in March, August, and November. We also have three individual periods of greatest elongation. So we notice here that the western, the eastern elongations kind of overlap within a day or so of the individual highest altitudes. When we'll see this is kind of a recurring theme throughout. So definitely some nice observing that we can expect to have here this winter with Mercury here us in the evening and morning skies here in February and March. Especially here with the February 19th and 20th period, where Mercury will be at dichotomy. So when you go out and observe it, when it's at its greatest elongation here, it'll actually be half illuminated. So definitely one of those for things for people who like to sketch planets. Interesting time period to go and follow along with it. And we also have several conjunctions with Mercury with other planets. We'll have a conjunction with Venus this February on the 26th. So a lot of interesting things with Mercury. We have a conjunction with Mars and Saturn together. So we will have Mercury, Mars, and Saturn together in the evening sky, all on April 20th. So really interesting thing to go look out for there. What moon phase is the 20th? Let me go check. The 20th is a Monday, and it is just after new moon. So you might get a little bit of moon there as well in the early. I don't know if this is going to be an early evening or early morning. Be a morning event, early morning event. So no moon in this period. And then we will also have an occultation of Mercury and the moon. This is when Mercury will actually move behind the moon briefly as it orbits across, or as the planet transits across the sky. So a lot going on in February with Mercury from the 18th to the 19th and the 20th. So something interesting going on there every day of the week, which is conveniently a Wednesday, a Thursday, and a Friday. But like many planetary events, occultations are only visible to certain geographies on the planet. And it's kind of hard to see here, but from our position here in southeastern Arizona, we're not quite in the path of the occultation. But if for those who might be willing to go and transit to southern New Mexico or the northern Mexican Sonoran Desert, you will get to see this dichotomy, not dichotomy, excuse me, this occultation of Mercury, which are not common events. So definitely something cool for people who want to go knock out something on an observation list. And this is the global star global in, right? Not this. So this would be I think this is a daytime event where you would have to be observing Mercury move behind the moon during the day as opposed to an evening time event. So 20 UTC on the 18th would be roughly 3 p.m. local time here in Tucson to around 5 p.m. in February. So maybe going into the early evening. So mark your calendars. After that, we go on to Venus. It will have visibility periods in the mornings from November to December, although technically it will extend well to visibilities. I'm not going to continue that here. And then it has visibilities in our evenings for most of the year from March to October, where it will be in our skies. It has several conjunctions this year with various planets. We have a conjunction with Neptune, Saturn, and Uranus, and June, all throughout the year, with Neptune coming up, and with Neptune and Saturn being in close proximity to each other. So those would all be interesting photography or observation nights here in March for Venus. And then we have Uranus here in April, and then Jupiter later in the year when Jupiter is moving in towards a setting position here in June. Uh, we have a lunar occultation of Venus also in June, which will be visible across the entire US. So you won't have to travel for this. And we'll have another lunar occultation in September, which will only be visible in the Eastern Europe and North Africa, Middle Eastern region of the world. Venus will reach its highest altitude in July 27th and a greatest elongation on August, excuse the typo, on August 14th. The reverse of those of the morning highest altitude at a western elongation will occur in 2027. And it will be at its greatest brightness for observing in the night sky on September 22nd, which is around the autumnal equinox, and again on November 27th. Going back to maps of occultations and where you can see them, this is the visibility map of the Venus lunar occultation here on June 17th. And you can see it's covering across the most of the US. This may or may not be one that we can see. It gets kind of weird with monsoon season timings and whether or not we get clouded out. But definitely something to pay attention to as we get closer towards summer. For those who make occultations. Our good friend Mars. Mars is in an awkward position, approaching its farthest position away from Earth. It'll actually be behind the sun at perihelion here on March 6th. So it's not, for most of the year, it's going to be a very small and faint version of Mars, with much better observing for us in 2027 as Mars comes back and starts approaching us later in this year. Despite that, it does have a couple of lunar occultations in October and November, which unfortunately won't be visible from the US. So you would have to travel with those. I don't think I put a map for them on here, though, where those would be. Given its position of entering perihelion, it will not have what's known as a retrograde switch this year at all. We'll actually start entering into a retrograde motion here early next year in 2027. So for those unfamiliar, the retrograde switch is a brief period in which a planet will actually appear to reverse directions in the night sky for a brief period as Earth continues its motion around the sun. This happens to every planet, most notably with Saturn, but the more interesting ones would be with Saturn and Mars for many people when they like to go observe them. So unfortunately, not a lot more interesting here with Mars, besides a couple of other conjunctions with Uranus, Neptune, Saturn, and Jupiter throughout the year. And then Jupiter, which is currently approaching its opposition this Saturday, which unfortunately will be a very high humidity evening, a lot of dew potential here in Tucson. So definitely would be a little bit more challenging for those who don't want to be wiping dew off of their equipment during the evenings. But nonetheless, it will be a very bright planet in our night skies. It will remain visible throughout most of the first half of this year in our skies, setting behind in late July. It will have several occultations with planets that I did not write down, and I apologize for that. I would have to go look those up. Those might be lunar occultations rather than planetary occultations. That was a typo and my mistake. I apologize. I'd have to go look at the website where I pulled this information from. But the October occultation will be visible from the eastern U.S. Uh, not from most of the eastern U.S. The western U.S. is kind of in a sore spot here. Arizona will actually be outside of the boundary of the occultation in October. It will also enter a retrograde motion here in November 30th, which was when where Jupiter would be a morning planet at that point when it would begin its retrograde motion rather than an evening planet. Uh, okay, so I think those occultations I listed were lunar occultations. Uh, but just there were just so many of them in the first half of the year, I just called out the ones in the later half. So this blue zone here is where you would be able to see the entirety of the occultation. As you can see, Arizona, which is like right around here for Tucson, is just outside of the zone. But if you want to, if you and yourself find up trapping in October, you would definitely be able to see Jupiter disappear behind the moon for a brief period. Moving on, we're winding up on the last planet we'll discuss. I left out Uranus and Neptune just because they're faint, fuzzy balls. And definitely we like to look more on some of the classical planets. For Saturn, it will be visible in our evening skies here until March, when it will finally set, and it will return to our skies in mid to late October, where it will come up in the mornings as a rising object. It will have conjunctions with Neptune, additional conjunctions with Neptune, Mars, and Mercury in the early half of this year before it sets. But it won't have any lunar occultations. Yeah. More interestingly, is that while it is in our morning skies in April, it'll begin its retrograde motion, where it will appear to reverse directions in the night sky starting in July, and it will appear at opposition on October 4th, which is when Saturn will appear at its brightest before concluding its retrograde motions once it reaches December. So almost 5 to 6 month period where Saturn will be going in the opposite direction in the sky. Questions on planetary events before I move on? Comments? Okay. Moving on to meteor showers this year. So meteor showers are, for the most part, regularly recurring events. They occur on roughly the same day, or they peak at roughly the same day every year because they are based on comets, as they are all meteors originate from comets, or in some cases an asteroid that's whose orbital path has crossed with the Earth. And so this comet or asteroid has left a trail of debris that Earth progressively moves through before moving out, which is where the peak of every meteor shower comes from, is from when it enters into this main debris stream. So this dust left behind will either intersect with Earth or be pulled into Earth by its gravity well. And the more frequently a comet returns generally leads to a longer lasting meteor shower, by which I mean all meteor showers are technically temporary events. They will only last as long as that comet can keep laying down material to replenish, because this meteor is, this comet stream will be impacting the Earth and clearing up the orbital period around it. So once that comet is depleted from, for say, repeated close passes with the sun where it becomes just a rock ball. Will there be any? I know, Jeffrey, there will not be. I did not see in researching any notable transits of any of the inner planets this year. I don't think there's going to be a transit of Mercury across the sun for a couple decades. I think the last notable one was that Mercury transit of the sun 3 or 4 years ago. So it'll be a good while for another Mercury transit. And I don't know what the time period on the next Venus transit would be off the top of my head. But no, sorry. Good question, though. Thank you for asking. But as I was saying, so there are recurring meteor showers, but also limited time meteor showers, which is come from comets that are just on a one-way trip through the solar system potentially that may or may not return, such as very long period comets from the cloud Oort cloud, which may have 10,000 plus year orbital periods. So all meteor showers will have one night of peak activity. This is when you can go out and you will have the highest fall rate of meteors through the that entire meteor shower. So meteor showers will last months on average, but have varying rates of slower rates of fall in those earlier periods before picking back up onto the peak periods. The Because of how orbital mechanics work, the best time to view any meteor shower. I see what you mean. Of transits of some of the outer planets as well, um, of moons on Jupiter and Saturn across Titan, for example. Right. Like, so transits of moons of Jupiter and Saturn across the respective planets. I don't know if any of those off the top of my head. That is an excellent question, though. Sorry for the distraction there. But so with meteor showers, because of how the Earth rotates and moves through this stream, they may have are best viewed after midnight and just before sunrise. I'll have a little picture kind of demonstrating this here on the next page. And because of the faintness of many meteors, moon phase is also an important factor for getting the most out of any individual uh, meteor shower. So to kind of demonstrate here why after midnight is the best time to view. So this is the Earth orbit around the sun, and it is moving in from left to right into this stream of meteor shower debris that was left by a comet. And the Earth is going to rotate. So over here on the right side of the Earth starts at dawn and it progresses into night. And so when we are over here in the early evening, we're on this side of the planet, which is on the opposite side of where this stream of debris is. And so we aren't getting these direct impacts. They're going more through this portion of the atmosphere here rather than hitting straight on where we can see more of it. So this is roughly the midnight position here at the bottom. So why viewing the Earth, but viewing a meteor shower is best from the midnight to dusk because you're on this side where you're essentially on the closest contact with a meteor shower's debris field. So starting off with the next notable meteor shower is the Lyrids, which come from comet C 1861 Thatcher. This is a 500, roughly 400 period year comet. So we won't expect to see this comet return to Earth anytime soon in our lives. But all meteor showers are named for a constellation in which their meteors appear to originate from. If you trace lines back to them, in this case, the Lyrids get their name from the constellation Lyra, which is where you would get to see the large majority, essentially an origin point of all the meteors. This has a uh, a very brief meteor shower as far as they go, only occurring throughout most of April, with peak dates on April 20th and 21st, which, as I did mention, uh, is closest to new moon. So we will have a little bit of a waxing crescent, which will be setting early in the evening. So we would potentially have really good viewing on this meteor shower. Just because of the moon phase and its position. This will have can sometimes have very high fall rates of about 100 meteors per hour, but 10 to 20 meteors per hour is much more common. You can't really know ahead of time how high your fall rates are actually going to be. So all of these are, if there's a variable rate here, You really just have to go out and look and see events closer to that time period. Uh, After the Lyrids, we have the Eta Aquariids. Uh, this is one of two meteor showers where the progenitor comet is Halley's Comet, which will make its next return to our skies here in 2061. Per its name, this meteor shower originates from the constellation Aquarius, with peak dates here in on May 5th and 6th, but continuing with has a little bit of an overlap with its start period with the Lyrid starting with the shower officially starting on April 15th and continuing all throughout most of May. Fortunately, this moon phase appears at this shower's peak occurs during a mostly illuminated moon, so won't necessarily get as good of a viewing experience just because we'll have a lot of moonlight to contend with throughout most of the shower. But what's notable about this is a meteor shower where the tails, the comet, not the tails, not the comet tails, excuse me, the meteorite tails can have a very long lasting period in the sky, which is makes it an interesting observational target. Or interesting to just go look out when it's not freezing cold out from winter. The next big meteor shower after that we can look forward to is the Perseids, which is certainly going to be one of the better ones this year because the peak period of the Perseids occurs during a new moon. So you will have no moon throughout the entire sky to see what is actually generally the highest fall rate meteor shower of the whole year. Unfortunately for us here in Arizona, it's also during peak monsoon season. So definitely one of those we'll probably have to travel for if you want to get the full experience. This meteor shower has its radiant set in the constellation Perseus, it's its name, and it originates, and its progenitor is the comet Swift 109P Swift Tuttle. So definitely something that I hope we can get some good weather on during this peak period to get a good show of it. It'll definitely be one of the better instances of the Perseids because they generally occur during a quarter moon phase for us. After that, we move on to the Orionids, which is the second of meteor shower that comes from Halley's Comet. This does originate in the constellation Orion and is a September to November meteor shower, with the peak fall rate occurring late October. Unfortunately, this is not also during a somewhat heavily illuminated moon with an 80% full moon on its peak night, which is unfortunate. But it's also one of the slower meteor showers at around 15 meteors per hour, so hard to fully qualify it as an active meteor shower. So we're not necessarily missing much like we would be with, say, the Perseids or the Geminids. After the Orionids, we can look forward to the Taurids, the northern Taurids. There's actually two, a southern Taurids and a northern Taurids, but the southern Taurids are generally best viewed from the southern hemisphere due to some timings. So this is from the asteroid 2004 TG, which I don't know when its next return is. I wrote this presentation. Some of this was from a presentation 3 years ago. So this might be an asteroid that's not in our skies right now, I would think. I have to go look. But the northern Taurids start in late October, concluding at the around time the Orionids start peaking, with the Taurids peaking themselves in the early half of November. But they were also during it's a very slow meteor shower with only 4 to 10 meteors per hour, so kind of hard to qualify. Might be hard to distinguish some of these from normal background fall rates of meteors, but that does occur during a 7% full moon. So we would potentially be able to get better viewing of these over multiple nights for those who like to go observe them. From there, we move on to the Leonids, which overlapping. So we got a lot of overlapping meteor showers that kind of start in November and throughout the latter months of the year. Unfortunately, this is one of the more interesting ones. We do have some of the brighter uh, meteors that come from the Leonids. They can be very bright at magnitude -3 for some of their tails, and they do also and it does have a variable fall rate with the when the meteor stream will get replenished. So mostly when the comet Temple Tuttle is uh, away from Earth, we have a very slow fall rate of about 15 to 25 meters per hour, but they can get quite dramatic with the fall rate. There will have been historical observations of the Leonids having a fall rate of up to almost 1,000 meters per hour, which occurred in the 1800s, where some people thought it was the end of the world because of just the sheer number of falling meteorites. And then concluding the year with the Geminid meteor shower, which will also be a very good one. This is one of the few meteor showers that comes not from a comet, but from an asteroid, in this case, asteroid 3200 Phaeton. This is starts in the mid-November and it concludes almost on Christmas Eve with the peak of the meteor shower on December 14th. It will be a quarter phase moon at 21% illumination. So it should be still a decent meteor shower to go see. And the Geminids typically have a fairly high fall rate of up to 120 meters per hour, and they do tend to be a bit yellowish in color. Many other meteors will typically have a reddish or a green tint as they interact with the upper atmosphere. So it does make the Geminids a bit unique, both with their high fall rate and distinct coloring. Oh, and the Ursids. There's two more here. The Ursids, which are very much our Christmas time meteor shower, but still a very low fall rate meteor shower this year with only 10 per hour and also during a full moon. So I wouldn't really expect much from this from as an observation target, but it's still nice to know that it's there. Questions or comments on meteor showers? Okay. And then wrapping up, we have several notable eclipses this year that we can look forward to. The first, for those who might like trips to Antarctica in the dead of winter, is an annular solar eclipse on February 17th that will be visible only from Antarctica. If you are lucky enough to have already booked trips for this in advance, which they do probably have this will be a very short annular eclipse with only 2 minutes and 5 seconds of annularity, as noted on this map, almost entirely over Antarctica. So it happens, but the important thing is that solar eclipses are generally paired almost immediately with lunar eclipses. And so 2 weeks after this, at the beginning of March, we will be able to see a total lunar eclipse from the Western US on March 3rd, which starts its penumbral phase for us at 1:44 a.m., reaches its full eclipse. These are all times in Tucson, Arizona time. Excuse me, should make that very clear. The full total eclipse itself will begin, which is the blood moon phase, will begin at 4 a.m. and last for about an hour, with the maximum eclipse occurring at 4:33 a.m. So hoping for some clear skies here in the beginning of March or a lunar eclipse. So this is a map of the overall visibility here of this lunar eclipse. So for most of the US, most of California will be able to see the entirety of the eclipse. Because of our position, we will not see the ending of the full penumbral phase. So they have the start penumbral, the totality, and then the ending penumbral phase. So we'll miss out at the ending portion of that penumbral phase because it'll be entering into daylight. And then most of the eastern US will also be in a similar boat. with not seeing, we'll be able to see all of totality in the beginning penumbral phase, but not the ending penumbral phase. Definitely one that I have marked on my calendar because I want to get some good pictures of it because our last lunar eclipse was almost a bit of a letdown because we were clouded out for most of the night. So, and then our last notable event is a total solar eclipse on August 12th, which will not be visible in the US. It will mostly be visible in Iceland and northern Spain, with the longest period of totality slightly off the coast of Iceland. But because of its position, you won't actually see the longest period of totality in Iceland. It'll be more apparent here on the next map. So your next best pick would be northern Spain, which is where we would have the uh, next best locations for longest periods of totality. But overall, this is still a somewhat short solar eclipse for totality, coming in at 1 minute and 45 seconds at the longest pace periods visible on land. For context, the solar eclipse in the US of 2017 was about 2 minutes and 47 seconds of totality. So it's up to you if you want to travel with it. But there are certainly eclipse hunters who do like to do this. So this is a rough map, not a rough map. This is a map showing the path of totality. So we can see here of the path most barely intersecting with the western parts of the island of Iceland, and then as the eclipse comes over here to the end off of northern Spain. So definitely for those who like to travel, something to go do if they want to go to Spain this year or have an excuse to cart their significant other off on an international trip. And that's it for tonight. I hope this gave you guys some ideas of things to look forward to or start planning on this year if you weren't already planning on some of them, specifically our eclipses. Uh, Questions, comments before we go?
Yeah, Connor. On meteors, I'm just curious, have you ever seen counts of how many meteors can be expected based on your viewing capability, like maybe the Bortle scale or something like that? Um,
I
I,
do know
I,
it is a factor in how many you can see, but I don't off the top of my head know if somebody's done like the diminishing return rates of like, hey, if I'm in Bortle 9 versus Bortle 8, what's the difference between them? It is very much one of those, meteors. I mean, my answer to your question is how often do you see meteorites in in central Tucson? And that gives you a rough idea because on average, outside of a period of a meteor shower, there is a background meteor fall rate of about 5 to 10 meteors per hour as a
Mhm.
general background rate. So that's why I was saying there's some of those that they hardly qualify as meteor showers because their own fall rate is roughly the same as the normal background fall rate. So they're kind of harder to tease out if it was exactly like an Ursid meteor versus just a background meteor, unless you're familiar with the radiants themselves of the meteor.
Yeah. Well,
So
for most of the bigger ones, I will often go out and lay on the Chase Lounge for 20 minutes or half an hour or something, and I usually only see like two, and they're, some people are talking, uh, tens to hundreds, you know.
the
Um,
100 typically comes in with the Perseids as a general rule of thumb, which for us is always one of those really hard ones to actually get good viewing on because of its, unfortunate proximity to monsoon season for Arizona.
right. Yeah. Okay. I got another question. I don't really want to go down the details of the rat hole on this, but it had never occurred to me before that the greatest elongation and the highest altitude would ever be different. Uh, do, do you know what the kind of the reason is for that? I know the ecliptic moves, throughout the year, um, but
It's
it
really
just
more of a kind of without my diagram itself doesn't really do a good job of illustrating that, but it's really more of a finesse. Like this angle isn't drawn to scale to show the exact position of the
Of
greatest
course.
elongation. It's arbitrary. So the period in which the greatest elongation occurs is there's that, as I think we saw here for Mercury, that the greatest elongation is like April 3rd, but there's no other highest altitude for that for for Mercury, which is in March. So it's like almost 2 weeks later. So it's really more of an angular thing, and versus it's a difference between angles in the sky and also the position of the observer. So
Hmm.
the elongation is more of like an absolute versus relative. And this is me spitballing here, so I'm almost certainly getting details wrong on the relationship between the two because I don't have Doug Smith here to correct me and telling, no, that's not wrong.
True. Yeah, I'll have to think through this one because I mean I get the idea that depending on your latitude or whatever, it might be something different, but
It's not the latitude that
Mhm.
defines like the difference between the two. It's the orbital position of the planet of Earth and the respective inner planet itself that separates it. It's not dependent on your position on Earth, although that does come into play as like how long the planet will be up in the sky on any given night, because winter skies in the southern hemisphere are, winter nights are longer than summer nights, for example, in terms of like
Okay.
how long that planet will actually be meaningfully visible in the early evening or early or late mornings.
So maybe regarding orbital position, maybe it's because, our orbits are elliptical, maybe something like that.
So that's one way to look at it. There's more nuance in here, and I don't want to unpack
Yeah,
the nuance.
I know it's a rat hole, and we don't need to go down it because
It's a rat hole I haven't studied because I myself am not necessarily really big on planetary observing, but I know a lot of people are. They do find enjoyment of that. So hence the presentation of calling out some
yeah,
of the things.
yeah.
And Jeff, I was going to put comments on here, but it's kind of really hard to give a good forecasting on some brightnesses on comets in terms of like, so there definitely is some. There are several comet tracker websites out there. I think like In the Sky is one of them, for example, where it'll show you like what comets are up. I can actually pull that up right now, actually. It's a Sky Live. Um, this is I don't know if this is, let me make this bigger because I know that Zoom screen sharing is not made equal for all people, and I have high resolution monitors. So the reason I didn't specifically call out comets is because you can't really predict which ones are worth going to go see, because you can't predict ahead of time what their peak brightnesses are. So a lot of times you'll have comets that are making their way through that won't even get the visible magnitude range. They might still be in like, magnitude 11, would might sometimes be the brightness product, which can be challenging to observe without, large optics, for example. So I just didn't want to call out, hey, go look at this comet. Oh, but it only reached magnitude like 11. So there are resources out there for comets that, for those interested in viewing them, I would recommend like this one here, like the Sky Live, for just a general comet tracker to come in and check in periodically. And for those that are here, um, there's that for those that they want to go bookmark. This is the one I do use when people say, oh hey, like Comet Lemon is in the night sky, because it actually is very useful in that regards of telling you where it is in terms of right ascension and declination for those that have go-to scopes. This was actually updated live because we know their orbits. So for those who know how to operate a go-to scope, say, hey, go to this right ascension and declination. It does make finding that comet significantly easier. And it is also updated regularly with what the most recent observed magnitude of the comet was, according to a couple of public citizen science projects that report on that sort of thing. And this is very accurate. Mostly of this is for some of these comments is updated nightly. So
Hey, Connor, sorry, what did you say the name of the site is that
it's in
you?
the chat.
Oh, it's in the chat. Okay,
I
perfect.
pasted a link to this page,
Okay,
that previous page in the chat for those who may want to bookmark it. But
right.
for those who can't probably see it, it is theskylive.com/comments. And it does include several things for those like star charts showing where it might be within a respective constellation for those who are maybe challenging themselves with manual observing without using go-to scopes to go find some of them, which would probably be tied into several astronomical league challenges for those who like those. But I don't know what those would be off the top of my head. So, no, but excellent question. Good. Thanks for asking again on the comments. And if there are no other questions, go ahead and stop the share here. Thank you, everybody. I hope you have some good ideas to look forward to throughout the year, and I will see you all next month.
Yep. Thanks again.
Awesome.